Question number 5, which says that the polynomial 3x cubed plus pax square plus 7a square x plus qa cube is denoted by f of x. So we have the f of x, which is this one, and where p, q, and a are the constant and a is not equal to 0. Where f of x is divided by x plus 2a, the remainder is negative 22a cube. When f of x is divided by 3x minus a, the remainder is negative a cube. Find the value of p and q. First concept, we should know that if x minus a is factor of f of x, so f of a means x minus a equal to 0, so x is equal to a. So we will plug a in f of x, so this one is equal to 0 if the x minus a is factor. Similarly, if f of x is divided by x minus b and we have the remainder of p, so we can say that f of p is equals to the p, because this factor doesn't satisfy the f of x, but it will give the remainder, which is p. So we will use these concepts to solve this question. So we have the f of x, which is equals to 3x cubed plus pax square plus 7a square x plus qa cube. Okay, we have the first factor, which is x plus 2a. So first factor is x plus 2a equal to 0 and x is equal to negative 2. So when we plug x is equal to negative 2a in f of x, we will have remainder negative 22a cube. So f of negative 2a is equals to the negative 22a cube. So plugging negative 2a in f of x, we will have 3 times x cube means negative 2a cube plus pa x square means negative 2a square plus 7a square x means negative 2a plus qa cube is equal to negative 22a cube. So solving this, we will have negative 2 cube is negative 8 times 3, negative 24a cube, and this one is equal to 4a cube p minus 14a cube plus qa cube is equal to negative 22a cube. So taking a cube common, we will have negative 24 plus 4p minus 14 plus q times a cube is equal to negative 22a cube. So a cube will be cancelled out and we will have negative 38 plus 4p plus q equals to negative 22. So we will have 4p plus q equals to negative 22 plus 38, which is equals to the 16. So we can say that 4p plus q is equals to 16. This is the equation 1. Now we will plug second factor, which says that when f of x is divided by 3x minus a, the remainder is negative x e cube. So f of x is equals to the 3x cube plus pax square plus 7a square x plus qa cube, and in this case factor is 3x minus a, which is equal to 0, and x is equal to a over 3. And when we plug this value of x, we will have remainder, which is negative a cube. So f of a over 3 is equal to negative a cube. Now plugging x is equal to a over 3 in the f of x, we will have 3 times a over 3 cube plus a over 3 square plus 7a square times x, which is a over 3 plus qa cube equals to a negative a cube. So this one is equal to 3a cube over 27 plus pa cube over 9 plus 7a cube over 3 plus qa 3 equals to negative 8. And this one will be equals to 9. So multiply by 9, we will have a cube plus pa cube plus 21a cube plus 9qa cube equals to negative 9a cube. Taking a cube common, we will have 1 plus p plus 21 plus 9 cube equals to negative 9a cube. 9a cube will be cancelled out, and we will have 1 plus p plus 21 plus 9q equals to negative 9, and we will have p plus 9q equals to negative 31. So this is the equation 2. So we need to find the value of p and q, so we can solve equation 1 and equation 2 simultaneously. From equation 1, we have q equals to 16 minus 4p. Plugging this value, plug q equals to 16 minus 4p in equation 2. So we will have p plus 9 times q means 16 minus 4p minus is equals to negative 31. Solving this one, we will have p 144 and negative 36 p is equals to negative 31. So we will have negative 35 p equals to negative 31 minus 144, which is equals to the 175 negative. So p is equals to negative 175 over negative 35, which is equals to 5. So we have the p which is equals to positive 5. Now plug this p in equation 1, we will have, so this one is plugged in equation 1. So equation 1 is 4 times p plus q is equal to 16. So 4 times p means 5 plus q equals to 16, and we have q equals to 16 minus 20. So q is equals to negative 4. So we have calculated the value of p and q, which are p is equals to 5 and q is equals to negative 4. So these are the required values. Now let's move to the question number 6.